Hi everyone, my name is Tara Mazurchuk, and I'll be talking to you today about the woe of plant invasions, a systematic review of spatio-temporal effects. To begin, a critical question in invasion ecology is whether a species' origin determines its functional aptitude to partake in well-known services to society, such as the sustainable production of food, recreational opportunities, and water purification by retention of pollutants and sediments. While some invasive plants are problematic, others could serve to restore ecological balance by providing food and shelter to other species residing in human-modified landscapes. Many ecosystems today have been dramatically altered by anthropogenic activities, making it difficult to restore ecosystems to their original state. This brings into question whether restoration and management efforts are responding to perceived or real species impacts, in which the latter includes not only species impacts but also biotic and abiotic confounding effects. We tend to assume that species posing a threat to ecosystems will also pose a threat to ecosystem services, but this is largely unexplored. Currently, there is a disconnect between invasive plant impacts and invasive species management and policy development. Several reasons contribute to this, including a focus on economic justification and return on investment of eradication efforts, as well as the difficult and often impossible task of fully isolating the effects of indirect and induced impacts of plant invasions at different spatial scales. By synthesizing knowledge across different landscape types and spatial scales, my research aims to provide a comprehensive understanding of the multifaceted impacts of plant invasions. I hypothesize that most ecologically driven impacts of invasive plant species do not reflect their true influence on a system, but rather reflect generalized regional scale impacts, which can encompass additional external and internal drivers of change. By generalizing species effects, the mechanisms by which these species operate cannot be adequately addressed, which could lead to unsuccessful or unnecessary eradication efforts. In this study, I investigate the cumulative impact of 10 wetland plant species classified as an invasive at the state level in the Mid-Atlantic region of the United States. A standard framework is provided to clarify as well as highlight the systematic processing of peer-reviewed literature used in this investigation. The literature search was carried out on March 5, 2020, and returned more than 8,800 articles for the 10 different invasive plant species examined from the Web of Science. Since most plant species serve an ecological function, studies within North America as well as the international community were included in this analysis to understand how species influence their natural habitat as well as how other cultures utilize these species for economic and socio-cultural means. One major contribution of this research is a weight of evidence score, or WOE score, which was devised for each invasive plant species to highlight gaps in scientific knowledge, as well as determine ecosystem vulnerability in association with different environmental contexts. And here is what I found. In the local scale assessment, invasive plant impacts were found to be highly conditional, meaning that impacts were positive in certain settings while negative in others. To showcase this point, the following table highlights the ambiguity surrounding a single invasive plant species. I'll use garlic mustard and its potential impacts here as an example. 21 studies showed a negative impact, 16 studies showed a neutral impact, and 18 studies showed a positive impact on native biodiversity. With such wide-ranging claims from the scientific community on species impacts, it becomes nearly impossible to establish a cohesive approach for invasive species management due to major inconsistencies among species effects, which could lead to fruitless eradication efforts. I also found that plant invasions are highly context dependent, showing that the magnitude of species impacts can at least partially be identified by habitat type. This figure shows a high degree of variability among studies indicating species impacts as negative, neutral, or positive in diverse landscape contexts. Common reed, reed canary grass, and purple loosestrife had the largest overall positive impact in freshwater wetlands, while contributing the least in forested areas, with a similar trend evident for negative impacts in these landscape contexts. This trend can also be observed when examining the weight of evidence score for each species by habitat type, as compared to the habitat types described in biological manuals for each plant species under investigation. This scoring system illuminates which species are likely to cause the greatest impact across an upland to wetland gradient. For instance, purple loosestrife has a more significant effect in freshwater wetlands than creeping jenny, reed canary grass, or common reed. Similarly, Japanese stiltgrass and garlic mustard are shown to have the largest negative impact in forests. In the regional scale assessment, I found that more ecological impacts compared to economic and socio-cultural impacts were discussed in the literature, with a large portion of published articles referring to species-specific impacts in northeastern United States. Out of 596 articles discussing negative species impacts in North America, almost 50% of these either referred to a decrease in native biodiversity, species expansion following a disturbance, or competition with native species. Out of 340 articles discussing positive species impacts in North America, more than 60% found that the 10 species were important for native biodiversity, saw a reduction in their abundance over time, and noticed improved soil properties associated with the species. At the national scale, the magnitude of negative impacts associated with these 10 plant species was found to be poorly linked to the states in which had designated them as invasive. Overall, there was significant inconsistency between the designation of a plant species as invasive and the location of studies that found a particular species impact. For instance, garlic mustard is listed as invasive by multiple states within the United States, but when examining the number of articles where authors mentioned a species-specific impact, no impacts were identified in Washington, Utah, and Colorado, even though these states list the species as invasive. Of interest, Ohio and Illinois appear as hotspot locations for research on garlic mustard impacts. However, these states have not listed garlic mustard as invasive. This example shows the discrepancy between invasive plant rankings and species impacts, as well as the haphazardness in the way different plant species are defined as invasive in different geographical areas. At the global scale, studies that identified a species-specific impact were most prevalent in the United States, China, and Canada. The majority of species effects identified in the literature were in locations where a major university was present, which may skew how we interpret the distribution of plant invasion. Not surprisingly, there are more negative impacts noted in North American studies compared to primarily positive impacts observed in an international context. There was also an increase in the number of research articles focusing on invasive plant species across all ecosystem types through time. The most valuable conclusion made from this literature analysis is the need for local scale and context-specific management goals and objectives that utilize scientific findings prior to mitigation implementation. Eradicating all invasive species is not practical under globalization and climate change, which promote the expansion of species into new ecological ranges. As an alternative, the findings from this study, in addition to the WOE scoring system, can be used to bolster as well as restructure the discourse around invasive species for more strategic management and ecologically sustainable outcomes. The weight of evidence score that I have devised here provides a general understanding of the ecological bounds of each plant species, where higher values allude to specific environmental contexts within which a species is likely to be most detrimental. This tool also highlights the variability in species ranges, with some species showing an expanded ecological range compared to what has been previously stated in biological manuals. My findings support the notion that species impacts are largely population-based rather than species-based, which to be expected has fueled such epic debate surrounding plant invasions due to their ever-changing intricacies. To manage ecological systems in a sustainable manner, we must reframe how plant species are seen to contribute to the ecological services we value most. If done properly, this research could be used to translate good science into management initiatives and policies that benefit not only the natural landscape but also human society. A great starting point is to take advantage of the unique ways in which the international community utilizes some of these aggressive plant species to fuel innovative and sustainable initiatives.